Hi friends, let me fix the lighting here. That should be a little bit better. No, it's not. I've got a bit of a halo effect going on. Let me sort that out. Better. Welcome amigos. This is the problem solver section. These are the pages in your workbook. I'll give you a chance to do them, and I'll try and give you little explanations on them as we go, as much as I feel like, or as much as I feel like you need. But I have, as always, the utmost faith and confidence in your abilities to rock the house on this stuff. So, this rectangular container is 2/5 filled with water. How much more water is needed to increase the height of the water level to 3 centimeters? Show 2 methods of solving this problem, and which do you prefer? Why? Blah, 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 blah. So they're asking you to basically guess the 2 methods they're looking for, or come up with 2 different ways to solve the problem, which, okay, great. I'm going to do one, because that's what I feel like doing. So this container is 2/5 filled with water. Your clue here is that there and that there. Okay, when it's telling me that it's 2/5 full of these 5 centimeters, that makes me think that this is the 2 centimeter mark right there. So if you want to increase the height of the water, so now that I know, based on that little deduction, that the height of the water is 2 centimeters, I want to go up an additional 1 centimeter to get to 3 centimeters. Well, I'm going to go up 1, but then it's also, so I'm going to add another, ooh, gross, don't look at that. And basically what I'm doing is adding another prism of water that is 1 centimeter tall by 8 centimeters wide by 10 centimeters long or deep, whatever. That can all be flippity-flippitied. About 1 times 8 times 10 is 80. There. Okay, here's the other. So that's one way to do it. The other method they want you to do is, what's the capacity of, how do they want you to do that? Let me think. Oh, okay. So the other way they want you to do it is, what's the full container worth? Well, it's going to be 8 times 10 is 80 times 5. The full container is going to be 400 centimeters cubed. This is centimeters cubed, by the way. And it's 2/5 filled. So 2/5 of 400 is 160 centimeters cubed. Oh, how much more water is needed to increase the height of the water to 3 centimeters? So you gotta still deduce that somehow that it's 2 centimeters deep. Well, I guess I know that if it's if 2/5 is 2 centimeters, then 1 centimeter, and then 2/5 is 160, then 1/5 would be 80, and if that's 2 centimeters, that's 1 centimeter. This makes sense in my head, but I'm not putting it out there properly. Talk to your teacher and have them fix whatever mess I just made in your brain, or do it the first way, because it's cleaner, neater, and nicer. Okay, good. We can all agree to move on. I thought so. Teamwork makes the dream work. I wonder if you guys are still saying that in the year 2030 or whenever you're watching this. Be very curious. All right. Okay. Hey, find the number of cubes in each prism. I'll race you. Problems 1 and 2. Go. All right, I gave you a head start. Come on. All right. You got all of that? Good. Great. Beautiful. Challenging. It says that was challenging. Hopefully it was manageable, but maybe it could be challenging because you can't see all those cubes and it's a little bit freaky-deaky like that. Okay, this one here, it says each solid's cut vertically along the line shown. So imagine these are like cakes. I don't know. Draw an additional line to complete the 2 shapes and identify the solid shapes that result. So in this case, you'd have a line. Once you got to the bottom of the square cake, you'd have one right here. And then what you're ending up with is really 2 triangular prisms. 2 triangular prisms. That's a triangle. Okay. On the next one, you want to try the next one? Okay, you got it? Good. This one here, you got to be able to really visualize that, but if you cut all the way down, you'd have a line right there. And you're ending up with two very funky triangular pyramids. Okay, where that would be the apex of each one. And when you slice that, you still just have two pyramids that are in a little bit different shape. So that's that. Boopity bop boop. Okay, rectangular tank is half filled with water. Another 650 cubic centimeters are needed to make it 3/5 full. Oh, for crying out loud. How much water will be in the tanks when it's 3/5 full? Okay, so this isn't even a, I'll just stop you right. This isn't a volume problem at all. This is a fraction, actually a fraction bar modeling problem. Oh, I just ruined your day, didn't I? I'm going to pause and solve this, and then I'll show you what I did. You do the same. Pause. Ready? Okay, go. All right, did you get to this point? All right, pause, and then deal with the fifth bit of it now. Okay, look, there's a hint, there's a hint, there's a hint. Pause me again and finish. All right, haven't done bar modeling in ages, but anyway. So the tank is half filled with water, and then another 650 cubic centimeters are needed to make it 3/5 full. So if this is 1/2, when you start dealing with halves and fifths, you have to find the common denominator of halves and fifths, which is tenths. So we end up dividing this bad boy into tenths. Here's 5/10. This is 6/10, which is also 3/5. So then we look at that little square right there, and we know that the unit, oh, do you remember this? Do you remember this? Do you remember this? Is 650 cc. And if that's 650, they're asking how much water is in the tank altogether. So if one of those is 650, then 1, 2, 3, 4, 5, 6. Oops, that's not a 6. 650 times 6. 3,900 cubic centimeters, or 3.9 liters. Hey, look at that, look at that. All right, do the next one. Pause. I'll just try and do the whole thing before the next round. All right, this is how I solved this one, but I don't like it now. What I did is, so it says the cube's got a surface area of 216 square centimeters. So what I wanted, and then the second cube's got edges that are 3 times as long as the original. So what I did in my head, or what I told myself, is I needed to find the edges on the original. So I did 216 divided by the 6 faces, so that I could determine, oh, wait, how did that happen? Boo, boo, boo. Okay, 216 divided by 6 for the 6 faces, which tells me that 36 inches per face, 36 inches squared per face. And then by finding the square root of 36, or 1 times itself is 36, then I got 6 inches per edge. Okay, so then I did 6 times 3 to get 18 inches per edge on the new cube. Okay, and then I did 18 times 18 to get the area of one side of the cube, and then multiplied it by 6 to get the 6 cubes. Okay, that's how I did it. In retrospect, that means, as I reflect, let's just imagine that this cube has a surface area of 216. Then a second cube has edges that are 3 times as long, which means my second cube is going to be, follow me here, my second cube will look like this. Okay, you don't necessarily need the picture. Okay, but if that represents whatever that length is, then that's the same and that's the same. And then that's the same, that's the same. So guess what each one of these squares is going to be? 216. So now, instead of kind of going through this disassembly and reassembly, I can do 216 Oh, 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 stop, McCarthy. Oh, oh, oh. Okay, I gotta fix something, and you're gonna learn as I talk here. I did something wrong. Oh, that's not 216. That's not 216. That's not 216. That's just the initial one. Okay, but let's just imagine that I'm making one that's got the edges that are 3 times as long. Okay. Okay. If I make my edges 3 times as long, all that means is I am doing the area of each face and multiplying that by 9, because I'm multiplying this edge by 3 and this edge by 3. Follow me here. So that the area of each face is multiplied by 9, or that the total area is multiplied by 9. So all I really have to do is do 216 times 9 equals centimeters squared. Okay, this makes sense. Have someone explain it better than I did, but that's the gist. Is that if the edges are 3 times longer, then the area is going to be 9 times bigger because you've got to do the times 3 and times 3. Boy, I'm not. Oh my gosh, it's 11 minutes, McCarthy. You're like Mr. Chatty Cathy tonight. Okay, which of these are nuts of cubes? I'm not going to check a teacher's guide or anything. I'm just going to do this. Pause, and we'll see who is superior. Go. All right, my box was hiding the last ones. Let me see that. Folds back, bottom left, top back. All right, I'm going to give him a happy mark. And I feel like we've done this one already. Top, left side, right side, bottom side, back side. Boom. There we go. E's to the P's to the lemon to the squeeze. If I got something wrong, do a victory dance. Send me a message on Schoology. Let me know your superiority. I'm open to it. All right, next. Square bases, edges each measure. Oh, you know what? We're going to skip this one because you guys haven't done ratio. No, I'll do it, but you guys haven't done ratios. It's not that fair. But here's what it means. The ratio of its height to its width is 4 to 1. Oh, square base. So that's 5. That's 5. All it's telling you is the height is 4 times the width. So the height is 5 times 4 equals 20. 5 times 5 is 25. Times 20 is 500 centimeters cubed. Boom. We'll do ratios. Maybe you have done ratios. I forget, this might be in the future or some other year where you guys did ratios before this. You actually did chapter 7 before 14. So that was a bit presumptuous of me to just say, oh, you haven't done it yet. Maybe you have. All right, now I'm racing the clock. Race the clock. Race the clock. Gotta be fast when you race the clock. Oh, except when you're on the last slide. All right. I hope y'all enjoyed this as much as I did. It's late at night. I'm done. I'm over it. I'm gonna go watch like The Mandalorian, or if that's old and you don't know what that is, whatever the current Star Wars / Marvel / Lifetime movie of the week is. It'll be one of those. That's it. Have a lovely, lovely day, evening, night, weekend, summer, fall, life, and all of that. And I'll see you for the chapter review tomorrow. Tomorrow we'll review. Tomorrow it's only a day away. Bye-bye.